Hey guys, so this is just a little video to make sure you understand the difference between atoms, ions, and isotopes. My other video has some information too, but another quick review. So, um, for atoms, the easiest way to do anything with atoms is to check the periodic table. Everything on the periodic table is the normal version. Okay, so here's one example, ptable.com. I will also be sharing one with the California Standards version, which will be paper. So that's the easiest way to check what's normal. Okay, so when you're looking at the periodic table, for example, this, whatever you see on the periodic table is the normal version. So normal protons, normal neutrons, normal electrons. Okay, so that's what's considered the atom. A couple other reminders. So remember that we can never, ever change the protons if we're looking at one element. If you change the protons, you change the entire element. Okay, so protons equal atomic number, which tells you which element it is. So they're never going to change if we're looking at one element at a time. If it's an atom, i.e. if it's on the periodic table, protons are equal to electrons. They will always be the same. Remember that when we first were looking at the atom, we thought there was nothing smaller than the atom. And part of the reason we thought there was nothing smaller is because the atom has equal numbers of positives and negatives, so they cancel out and become neutral. So that's why we didn't know there was anything inside there until we did some experiments to figure it out. Okay, so protons and electrons are always equal for atoms, but not equal for ions. Okay. If you have an ion, it could have more electrons than protons, or it can have less electrons than protons. So this will not be the same. And usually how you'll know that is you'll see like a +1 or a -1 or something like that. That's usually how you know if something's an ion or not. Or if you just count the number of protons and the number of electrons, if they're not the same, then you know it's an ion. Okay, and then down here, the neutrons, there's a common misconception. People think that protons have to equal neutrons. They don't. If you look at lithium on the periodic table, the atomic number is 3, which means the protons are 3. But if you look at the mass, it's 7. 7 minus 3 is 4. So it's got 4 neutrons. So the normal version does not always have them equal. Okay, so protons do not always equal neutrons. But the normal version is what we look at on the periodic table. So if we look at something, if it's an isotope of that version, if it's different. So if I had a lithium with mass of 8 instead of mass of 7, then I would say, oh, that's an isotope because it's different than the version on the periodic table. So again, ions, the protons have to stay the same, otherwise we change the element, okay? Electrons will differ from the protons if it's an ion, okay? A little reminder, if you have extra electrons, if you have more electrons than protons, that's an anion. And if you have less electrons than protons, it's a cation, okay? Another way to look at that, positive charge, if it has a +1, +2, +3, something like that, that's a cation. If it has a -1, -2, -3, that's an anion. So those are ways to tell those apart as well. Remember that the goal of the ion is to be like the cool kid. Everybody wants to be like the noble gases, okay? So that means that they're going to act like the noble gases. Here's an example of a noble gas. This is neon. Notice that its first energy level has 2 electrons. That's the max it can hold. 2 is the most, okay? The second energy level has 8 electrons. Again, that's full for that energy level. So full and full. When anything is acting like a noble gas, it's going to try to be full as well. So when you are trying to count, if you do have an ion, when you are trying to count to see how many electrons it has or whatever, use that rule of thumb, especially for the 3 inner layers, the 2, 8, and 8. Remember, this can hold 2, this can hold 8, and the outer layer can hold 8 as well. That means that if something is an ion in those first 3 levels, it's going to be either 2, 10, or 18, okay? It's going to follow those rules, and it gets a little more complicated as we get higher, but at least for the first 3 rules, if it's an ion, it's going to either be 2, 10, or 18. That might help a little bit, but sometimes you just have to take a look at it. For isotopes, again, we do not change the proton number. If you change the proton number, you're making it a new element, okay? So then it's not comparable. If I change this carbon here, if I change this protons to 7, it's no longer carbon, it's now nitrogen. So we cannot change the protons, which is why you see that they're the same, okay? But you do have a different number of protons. So this is the quote-unquote normal version. So the normal version of this one has 6 protons, 6 neutrons, and if it's not an ion, it has 6 electrons as well. And for this one over here, these are 2 different isotopes of carbon. Carbon 13 still has 6 protons, but 13 minus 6 gets me my 7 neutrons. And then over here, carbon 14, my protons still have to stay 6. So 14 minus 6 gives me my 8. All right, so next I'm going to make another video just so it's separate. I'm going to do this on a piece of paper with my document cam. So tune into my next video if you want to see how to break these down.